Okay, so here is a problem that is similar to the one that we did in the last video. And so what I'm thinking is, why don't you pause the video and try your best to work through this problem. See how you do, and then when you're done, go ahead and you can play the video, and then I'm going to work through the problem. So go ahead, pause. Good luck on the problem. Okay, so now let's see how you did. So this says to estimate how much time students spend studying during a typical week. A sample of 55 college students is taken and has a mean of 7.41 hours and a standard deviation of 2.78 hours. So first of all, what is the point estimate? Well, the point estimate is just the sample mean. So nothing to calculate here. The point estimate is just x bar, which is 7.41 hours. So that would be the answer to number 1. So for number 2, it wants you to construct a 98% confidence interval here. So the center of my interval would be the 7.41, the margin of error. For 98% confidence, it's 2.33 for my critical z-value, and then it's going to be times 2.78 over the square root of 55. That's the sample size. So let's see here. 2.33 times 2.78 divided by the square root of 55, and I get 0.87. Notice I'm rounding to 2 decimal places so that it matches my mean and standard deviation here. So now I got 7.41 minus 0.87, 7.41 plus 0.87. Okay, so my interval here would be, the lower endpoint is 6.54, the upper endpoint is 8.28. So that would be the 98% confidence interval. So now it wants you to interpret that. So you could say I'm 98% confident, true mean lies in this interval. And you probably want to, I knew I was going to run out of room, but you probably want to say 98% confident the true mean number of hours spent studying by all students lies in that interval. Okay? So now, construct a 95% confidence interval. So the center here is 7.41 again. For 95% confidence level, the critical value is 1.96. Multiply that by 2.78 over the square root of 55. So notice the only thing that really changes in this interval is the critical z-value, which is actually going to make the margin of error a little smaller because the critical z-value is a little smaller. 1.96 times 2.78 divided by square root of 55. So I get 0.73. So now this is 7.41 minus 0.73, 7.41 plus 0.73. So my interval here would be, the lower endpoint would be 6.68, the upper endpoint would be 8.41 or 8.14. Okay, so this would be the 95% confidence interval. So now, which of these two is more precise? Well, the 95% confidence interval is more precise, because what I've done, I shrunk down the margin of error from 0.87 to 0.73, and this interval is a little more narrow, it's a little smaller. Okay, so basically what I did is I traded away confidence to gain some precision. Okay, so yes, this is more precise, but I'm less confident. Okay, yes, I have a higher level of confidence here, but it's just a little wider. So it's kind of give or take here. It's like 6 of one, half a dozen of the other. Okay, so to answer this question, we could say that the 95% is more precise. Why? Because we traded away confidence to gain precision. Okay, 6 of one, half a dozen of the other. Right? So if I want a more precise interval, the better way to do it would be to increase my sample size. So the last question here is asking, how large would the sample need to be for the margin of error to be within 15 minutes at 98% confidence level? Okay? So we have this formula, if you remember. It's the critical z-value times the standard deviation divided by the desired margin of error squared. Okay? Now I was a little tricky here. I don't know if anybody noticed this, but I said 15 minutes. So you may have put 15 down here and got an answer that didn't look very correct. Okay? And the reason why here is 15 minutes here needs to be converted to hours. So 15 minutes is actually 0.25. It's 1/4 of an hour, right? So what you really want to use here is 0.25, right? So I'm not sure how many caught that. That was a little tricky. I probably won't be tricky like that when it comes to a test. I can't remember if there's any like that on the homework, though. So for 98% confidence here, the critical z-value is 2.33, and then my standard deviation is 2.78, and then this is over 0.25. I want my margin of error to be 0.25. So I went from 8.7 to 0.73, and now here I'm going to go all the way down to 0.25. So I'm going to really shrink it down and still maintain the same level of confidence. So how large would my sample need to be? Well, let's see. So 2.33 times 2.78 divided by 0.25, I get this. Now I got to square it, and I see I get 671.3073 whatever. So now notice this one here, you would normally round that down, but this is the problem where you always round up just to make it that much more precise. So if I'm willing to draw out 672 students, then I can gain a lot of precision, okay, and still maintain 98% confidence. So, and it is, a sample, this is a large sample, but it's not unreasonable. A lot of studies usually have quite a few observations in their samples. So I really, really like this problem. This takes you through kind of everything, all the different concepts when you're working with confidence intervals, estimation and confidence intervals. So this is a really nice problem. So in the next set of videos, we are going to look at what you can do to calculate a confidence interval when your sample is less than 30. Okay, so all these are examples where n is greater than 30. So if n is less than 30, they got a technique that you can use, but it involves a different distribution, something called a t-distribution. And we're going to be looking at that in the next set of videos.